Fine. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good in your studies. Okay, so let's begin today's lecture. If I'm talking about what we have already studied, we have already seen Faraday's law. I have explained in the last lecture only about Faraday's law and Lenz's law because that is the fundamental basis of this complete chapter, electromagnetic induction. If you are confident in the directions, that means rest of the things are just formula things and some derivations are there that you can easily understand. But if you are having some pain in the directions, then this complete chapter is going to horrifying you. Okay, so if you have not watched the first lecture, go and watch the first lecture. Okay, there we have only discussed about Faraday's law and then Lenz's law in complete depth. Now we are going to understand. In last lecture, if I will summarize the complete lecture, what I have told you, that if there is a time varying magnetic field, that means I can say if there is some change in flux with time. And how flux can be changed? Flux can be changed with three parameters. That was exactly three experiments of Faraday's. What was those three parameters? Firstly, Faraday's did what? He have changed the magnetic field, correct? Secondly, he have changed the area. And thirdly, you have changed this angle between what? Angle between the area vector and the magnetic field, correct? And all these three cases, he have observed that some current is flowing and some EMF is getting induced, correct? This was about. And what was the second law of Faraday? Second law of Faraday actually give you the formula or the quantitative analysis, that he said that EMF is equals to minus of d phi by dt. Correct, and there was a significance for that minus sign also. I have told you in the last lecture, correct? What was the significance of that minus sign? Minus sign told you that it always creates in such a way that it is going to oppose the cause. Now what and how this was explained? This was explained by Lenz's law. The directions was explained by Lenz's law. Lenz's law says that okay, magnetic field is increasing, that means flux is increasing. Flux is increasing, that means there is a change in flux with time. If there is a change in flux, a current will got induced, and that induced current will try to do what? It will try to oppose the cause. Who have opposed this current, who have created this current. Okay, why this current got induced into the circuit? Due to the increase in magnetic field. That means it will induce in such a way that it will try to decrease this magnetic field. And vice versa, if a magnetic field is decreasing, flux is decreasing, change in flux, EMF and current got induced, and this induced current will try to do what? It will try to increase this magnetic field. It will always oppose the cause. Okay, it doesn't matter that magnetic field is decreasing or increasing, correct? And if you are very clear about the directions, easily you can understand that how it is going to be induced. Okay, I don't think so that in that case you will have any doubt. Okay, because in the first lecture we have only discussed about the directions as well. Now we are going to see about motional EMF. We are going to see a conductor when it is moving perpendicular to the magnetic field, in the direction of magnetic field, rotating in the magnetic field. In all these cases, what is happening? Something is changing, flux is changing. That means of course there is some EMF will be generated. If there is some EMF will be generated, some current will be coming, and all these things we are going to understand in this lecture. Are you excited to learn something new? So be ready with your pen and paper, and without wasting any time, let's start. Okay, how is the energy, students? Let's begin. Okay, first one is motional EMF. First one is what? Motional EMF. What is this motional EMF? I will tell you. Theories are given for your board purpose. These are the things that you will be writing in your board purpose. I am telling you in the lame language, simple language that we can understand. Whenever there is complete magnetic field in this complete area, there is a magnetic field. Tell me what is the direction of magnetic field? Inside the board. If there is a wire or any kind of current carrying conductor, only conductor is there, and if it is cutting the magnetic field lines, what will be happening? It will generate some EMF into that current carrying wire. If EMF is induced, some current will also get induced. And how? Let's see. And how much? That also let's see. Okay, two things are important, because everything we are trying to, in every case we are trying to find the directions as well as how much we are getting that, and from that different variety of questions are generated. And then we will be studying about inductor also. That is a actually, if I will tell you, this is a third important device that you are going to say. Firstly, I have studied about resistor, you studied about capacitor, and in this chapter you are going to study about inductor as well. So let's start without wasting any time. Fine, where is our pen? Where our pen gone? See what you can say. Here is a conductor of length L. Here is a conductor of length L, and now this conductor is moving in forward direction with some velocity v. So I can say if the magnetic field lines are inside direction and I am going like this way, that means can I say I am going to cut this magnetic lines of magnetic field lines, correct? And due to that, what will happen, I will generate some EMF also, that is represented after covering some distance it have generated. Now the questions can be, sir, why the higher polarity is only in upward direction and why not in downward direction? All these answers we are going to get. Now there are two ways of thinking about it. I will tell you the first way, then we will understand the second way as well. Okay, how to think about it? What I can define for flux, what I can define for flux, flux is written as a B into A, B into A. Okay, tell me what is the magnetic field? Magnetic field magnitude is already given as B. What you can write for the area vector? What you can write for the area vector? Area vector, how much area that is swept? This area, tell me how much area you can write. The length you can write as L, and what about this width? What about this width? How much distance you have traveled? If I can say the velocity is v, and let's suppose this is a time t and this is a some time t plus dt, that means how much time you have taken, some small time dt. That means if I'll ask you tell me what is the distance, I can write distance is equal to speed into time, that means it is equal to nothing but v into dt, correct? So here you will be writing area is equal to v into dt, and this is equals to flux, correct? And then area is equal to, you have to also multiply with the length also, because length into breadth, that will be area. Now I know that if I have to write the EMF, how I will be writing the EMF? EMF will be written as d phi by dt, that means divide both the sides with dt. If you are dividing both the sides with dt, tell me, if you are dividing here dt, what you will be doing? Dt cancel. What is the result that you are getting, students? BLV. This is what you will be getting as a result finally, but it is not telling you about the directions. We'll discuss further also, but for a moment I will tell you, if you want to find the direction of higher potential, lower potential, there is a very simple thing you have to do. For direction, I am separately writing here, please mention it in your notes. Direction will be finding by V cross B. Just simply do V cross B, it is going to give you the direction. How it will give you the direction? See, this moving in forward direction, velocity V, and magnetic field is inside the plane. That means what I can say, V cross B. What is the direction that you are getting, students? V cross B. What is the direction? Upward direction. That means I can say this will be aligned in such a way that the current will be moving in the upward direction, and this will be the higher potential automatically, and this is the lower potential, because higher potential always reflect that current is generating from here. And I can say this will be high potential, that's why it is represented as plus and it is represented as minus. This is the concept of motional EMF. Whenever a current carrying conductor will be cutting the magnetic lines of forces, it will be generating some EMF into that, correct? Let me check, voice is clear to all of you? Correct. Voice is very clear to everyone. Fine, let's move. So I've told you there are two ways of thinking about it. Now what is the second way? What is the second way? Let's see. Now second way is described very good by this example. Let's understand this. What this is saying, let's suppose I have taken any cross section of any wire, and just listen me. What will be happening? It is moving in forward direction, correct? And let's talk about any single electron. Let's take any single, because it is a conductor, that means free electrons are available here, correct now? So what I know about force, what I know about force on a charge is QVB. And if I will ask you about the direction, Lorentz was in the last chapter we have studied about it. For the direction, what we will be doing? V cross B. V cross B gives you the direction of the magnetic force. This is V cross B. V cross B give you what? Upward direction. That means the magnetic force will be applied in upward direction. But since it is an electron, electrons means there is a negative sign. If there is a negative sign, that means it is going to come in the downward direction. That means I can say the force that is applied on this electron is magnetic force, that will be coming in downward direction. Okay, That means till here is it clear that force is going to be applied in downward direction. Very good. Now what you can say, an electron is moving in downward direction. If a single electron is coming in downward direction, slowly what will happen? Other electrons will also feel some force in downward direction. So electrons will start getting collected in the downward direction, because why? A magnetic force is acting in the downward direction. Due to that, what will happen? Can you say, if here it is excess of electrons, on this side what will happen? It will be excess of electrons. It will be what? Excess of electrons. It will be what? Excess of electrons. If this is excess of electrons, can you say an electric field will be generated? Electric field will be generated. What is the direction of electric field? Electric field is generated from higher potential to lower potential. That means this will be the direction for electric field is now generated. Due to electric field, what will happen? Due to electric field, what will happen? Now, can you say a force will be now acting on this electron that is present here? Slowly a force is acted. Naturally force should be equal to q into E, that should be in downward direction, but since it is a negative charge, I will reverse the direction and I will say that this is electrostatic force, that is equals to q into E, that is equals to q into E, that is represented in upward direction. Now see, as soon as it is starting to get collected, the more electrons will be collected in downward direction, the more this electric field will be getting stronger. Initially this was only single charge was there, so you will write q into simple 1 into q. Now 2 electrons, 3 electrons, 4 electrons. That means, can you say, slowly this electric field magnitude is increasing. If electric field magnitude is increasing, can I say my force in upward direction, that is electrostatic force, that is also increasing. Correct? That is also, I can say, increasing. Correct now? So if I am saying that that is increasing, there will be a moment where it will achieve its equilibrium. A moment will be coming where I will saying that this magnetic force is equals to the electrostatic force. What is the magnetic force, students? It is equals to QVB, that is acting on the electron. And what about the electrostatic force? That is equals to Q into E. Q into E. Correct? Or you can write as the place of q as an electron also, because we are talking about electrons. So this charge will get cancelled and electric field vector will be coming as V cross B. Electric field vector will be coming as V cross B. This V is what? Remember, this V is what? Velocity. This V is what? Velocity. Okay. And I know there is a relation from electrostatics that I know that delta V is equals to what? E into L. E dot L. And now what is here? My electric field. Electric field is nothing but V cross B, and I can say this complete term is dot product with L. So this is the final result that you have to remember. This will solve all the cases. What is the result? Give 2 star to this result. What is the result? Change in EMF. This is what? This EMF that is generated into the conductor. This is the EMF that is generated into the conductor. What is this EMF, students? It is equals to V cross B. V cross B you will be doing, and then taking this, because cross product gives you what? A vector. Okay, and then take that vector, a dot product with this L vector, and then after that finally you will be getting the results. The meaning for me that I was saying that if a conductor is cutting, not touching, there is a difference in cutting and touching. Okay, I am again telling you, you will be getting confused in this. When a magnetic lines, when a conductor is cutting the magnetic lines, then only a EMF will be generated. And in physical terms, if I have to say the same thing, I will be saying that the vector that is coming from V cross B, you have to take the dot product with the length, and then you will be getting the result. Magnitude wise, it is very easy. Magnitude wise, it is simply BLV. Is it clear? We have gone very slow. We have understood everything with complete depth. I hope that this will be clear to you. Now let's understand. In the question series, the more you will understand about it. Don't worry for that. Okay. Here what you can say. It is the same thing that I have explained you. VBL and electric field was coming also V into B. Correct. And finally the result that we get is VBL. If I have to write in vector form. In vector form, if I have to write, you will be writing EMF or delta V is equals to V cross B dot L. This is the result, complete result that you have to remember. If I will be asking you about the higher potential and the lower potential, how you will be describing that? Just do V cross B direction. In the first slide only, in the first page only, I have told you that how to find the direction V cross B. That will giving you the position of the higher potential, and automatically the other one will be at lower potential, and everything you can calculate from there. Is it clear? And when it is coming, this EMF is generating, there is some internal resistance also, because I have told you in the current lecture topic, whenever then EMF is generated, it will come with some very basic amount maybe, but it will obviously come with some internal resistance. Any doubt, students? If you are facing any doubt, please comment down your doubts in the comment section. I am watching it continuously. Clear? So let's see. It is a circuit, a complete circuit is drawn here, and the kind of question, if you have to connect that, now we have completed this circuit, some external resistance is also connected. If someone is asking you, tell me how much current is going to flow into the circuit, this is your circuit, how will be doing that? Current can be written as total EMF generated into the circuit divided by the net resistance. How much net EMF you will be saying? Net EMF is said as VBL. Just a few times back we have understood about this. So how I can write VBL? VBL can be written as, see, velocity is V, magnetic field is given as uniform B, and what is the length? L. So what I will be writing at this place? I will be writing BLV divided by what is the net resistance? I will say net resistance, I will say that is capital R, and if an EMF is coming, that it will be coming with the internal resistance R plus R. And what will be the direction? That is also, that can also be given by Lenz's law, but here we have directly remember the direction result. How we will be doing? V cross B, V cross B, V cross B, that is giving you upward direction. That means this point is at higher potential. How we reflect that? This is the representing higher potential, this is reflecting lower potential, and if this is the higher potential, I can draw the current as well. Current is going to flow in this direction. Correct? Current is going to flow in this direction. So net current result, net current, you can write that moving into the circuit will be BLV divided by R plus R. So the complete game, if I will tell you, it is about only writing about how you are writing the EMF. Once you understand the EMF, then you have to just divide by the equivalent resistance that is present in the circuit, and rest of the things you can easily do. Is it clear? Our pen is not coming. Let's take a 2-minute break. Let's restart the system. Students, how is your preparation is going on? Tell me. I think that now the most of the students will be busy in their board exam, I guess. Correct? So how you are managing your board exam and the competitive exam that is ahead of you? That is the biggest headache for students on this time. Specifically, if I'm talking about the 12th students. Electromagnetic induction. खुल जा भाई. What we were studying, students? We were studying about emotional EMF. Emotional EMF. What we are studying? Emotional EMF. Yeah, this EMF is actually emotional. Okay. Let's see our emotional EMF. Here in the description box, every details are given. If you want to connect with our team, you can connect on our Instagram channel, Telegram channel. All these links are provided in the description box. So for any further discuss, because we are going to start a crash course very soon. That will be a lot beneficial. We are going to target the important topics. We are not only going to just rush into all the topics. We are going to focus on the important topics. So if you want, you can join that course also. All the details are provided into the description box. Finally, we got our pen back, and I hope that it will be, no, it is not remaining with us, unfortunately. Fine. So if I am talking about the direction, how we can find the direction. Direction will be given as Lenz's law, but I've told you the simple trick for finding the direction. How you will be finding the direction? Just simply do V cross B, and that's it. It is going to give you the direction. How you will be finding? See, what is here? Our conductor is there moving in the forward direction with a velocity V, length is L, and the magnitude of magnetic field is B. How will you be finding the direction? Simply do V cross B. If you are doing V cross B, what you will be getting? This will be V, this is the higher potential, this is the lower potential. That means I can easily say this is going to be the current direction, this is going to be the current direction, and simply that's it. That you can define from Lenz's law also, but here we know the direct result, so why to get confused in Lenz's law? For other things already there is Lenz's law. Let's suppose I have shown you that other direction. It is moving in this direction in negative x-axis. So how will be doing? This is the direction of V cross B. That means I will say this time this point P is behaving like a higher potential and this point is behaving like a lower potential. If it is behaving like a higher potential, what will be happening? This will be coming the direction for current. This will be, that means what is the direction of flow of current? This is the clockwise direction. That means how the current is going to flow. Okay, these basic directions already we have understood a lot. Okay, now there is a basic question. Try to solve this question by yourself firstly. Okay, let's check how you can solve this question. Find the current in 5 ohm resistance. Find the current in 5 ohm resistance. Tell me how you will be calculating. 5 ohm resistance, you have to calculate solve karo. Check that are you able to find the answers by yourself or not. The question is find the current in the 5 ohm. How much current is flowing into the circuit? I've already told you how to find, not a very typical question. Simply see, all the things are given, you just have to calculate what is going to be the firstly the EMF, because current, if you want to calculate, you have to firstly calculate the EMF, then only you can reach to the current. And how much EMF is generated, that already you understand. How much EMF is generated? BLV. That means magnetic field is given as 0.1, length given as 2, and velocity is given as 10. This will be the EMF that you will be getting. And how much EMF you can say? You can simply say it is going to be 2 volt of EMF. Now if you have to calculate current, how you will be calculating? The net EMF present, that is 2 volt divided by nothing else. It is given about the resistance, that means only resistance, that is given as 5. 2 divided by 5, what will be saying? I guess 0.4 should be the correct answer if you have not done any calculation mistake. So according to us, option B, that is the correct answer. Simply we have did what? We have calculated the EMF, and even what is the direction, that we can also discuss. What is the direction that we can say? Correct. What about the direction? Because solve to tum log easily kar loge, but how you can find the direction as well. So direction, if you are talking about V cross B, what is the higher potential? This point is at higher potential, this point is at lower potential. If this is at higher potential, you will be drawing the directions like this. That means this is the direction of flow of current, that is anti-clockwise direction in this case. Clear? Don't remember that it is clockwise and when it is anti-clockwise. Just simply do the directions that I am giving you for every formula. Specifically I am telling you how to find the direction, so please follow that only. Okay, so when you are taking this conductor at some angle with this magnetic field, and this is the area vector that you will be having, and the velocity vector is again at some angle alpha. When all these things are happening, that's why I've given in general result. How to find that? In general result was what? V cross B dot L. Already I have told you when I was deriving the formula, so we have already discussed. Let's see in all these 3 cases what are the cases that have been made. Check karte hain. Okay, Do you want to start? See, what is the first thing? V cross B. VB. What is the angle between them? I will say theta is equals to 0. V cross B. That is cross product. What is the sine 0? Sine 0 is 1. That is 5. But when you are going to do, and what will be the direction that you will be getting? What is the direction? Resultant. Sorry, theta is equal to 0. Theta is equal to 0. That means firstly it is become 0. If velocity and magnetic field, if velocity and magnetic field are in the same direction, that means sin theta is equal to 0. That means obviously the result is going to be 0. Sorry, clear? Now next one. This is the velocity, this is the magnetic field. That means what is the angle between them? Theta is equals to 90 degrees. That means you will be getting 1 from here. But now you have to take this V cross B. V cross B. What is the direction that you are getting? Inside the plane. Inside the plane. That means now what is the angle between this length, area vector, length vector, L vector, and this inside vector that is getting from the first result. The second one you will be writing cos of 90. 90 degrees becoming. That means cos of 90 is what? Again 0. Again 0. And now if you will try to little bit understand now, this is not going to cut the magnetic lines of forces. This one is also not going to cut the magnetic lines of forces. You have to understand this. When it is cutting the magnetic lines of forces or touching the difference between cutting and touching, you have to understand. Otherwise there is a this way. Kar lo khud se. If you get the field by solving 10-15 questions, automatically you will be getting the field. Okay, so I will say that is a better method. But still, I have to explain. V cross B. Now here, what is the initial angle between them? Initial angle between them is again 90. That means first time when you are doing V cross B, you will be getting sine of 90. That is fine. VB will be the result. Now you have to take the resultant vector. What is the direction of resultant vector? V cross B. Resultant vector will be coming in inside direction. And about that, if I am asking, this is the L vector. L vector, what is the angle between them? Again 90. That means cos of 90 again becomes 0. That means in all these three cases, what is the EMF that you are getting? EMF that you are getting is 0 in all these three cases. Is it clear? Now what kind of problems you are getting on motional EMF? The most basic question anyone can ask you about the EMF. Second kind of question anyone can ask you about current, that how much current is flowing into the circuit. These kind of things are basically asked. So let's see what is this saying. You have to calculate what is the induced EMF and current in the rod. How you can calculate? Simply calculate the EMF. EMF will be coming a lot of questions now. Till now we have solved. EMF will be coming equals to VB and VBL, and the net current that will be flowing R net. What is the R equivalent? Is simply internal resistance and external resistance divided EMF divided by R plus R. That is very basic thing. Till now we have solved it. Next, a good kind of question that is coming. The question is, find external force required to keep the rod moving with the constant velocity. The rod that is moving here, in forward direction, you have to tell me what external force you will be applying so that it is moving with constant velocity. पहले तो ये बताओ कि what is the meaning of constant velocity? जल्दी, tell me, what is the meaning? Constant velocity simply means that acceleration is equal to 0. Simply means what? Acceleration is equal to 0. When acceleration, how you can make acceleration is equal to 0? That means net force is equal to 0. Correct? Let's see what you can do. I will say, let's calculate here only. पहले तो ये find करो कि what is the direction of magnetic force? What is the direction? V cross B. Can I say, what is the formula for magnetic force? Magnetic force is BIL on any kind of conductor. And how you find the direction? You find the direction for that as I cross B. Anyways, I is not a magnetic vector thing, but I told you to take that same direction. So उससे भी पहले आप क्या करना होगा? You have to go even backward. You don't know even the direction of current, how the current is getting induced. So firstly you have to calculate the direction of current. Let's do that also. We did V cross B, and this is the direction of current that we are getting into the circuit. Okay, and this is the conducting rod. Okay, so this is the direction that is induced in current. Now how I can do? I can do I cross B. I cross B. That means I can say what is the direction of magnetic force that I am getting. This is the direction for magnetic force I am getting. That means what should be the direction of external force that I have to apply? Simply, that means I can say this will be the direction for the external force that we have to apply. This is the direction for external force that we have to apply. And if I want that net force is equal to 0, what I have to say? That the magnetic force should be equals to the external force, correct? And how much magnetic force I am going to write? I am going to write it as B into I into L. That should be the magnitude of the external force direction. Already I have told you. So how I can write it further? Tell me what I will write the magnetic field. Magnetic field magnitude is given as B. How I can write the current? Current can be written as EMF divided by the net resistance. Net resistance is R plus L. And how I can write the net current EMF? Net EMF is written as BLV into L. So finally this F net, finally that you will be writing, that is equals to B square L square V divided by R plus R. This will be the final answer that you will be writing to take this rod in a constant velocity. Constant velocity means what? Acceleration is equal to 0. That means the net force that you will be writing, that is equals to simply 0. Yeah, it is becoming too cold. Is it clear? समझ आया? Very good. So now I have told you that motion is not only that it is a linear motion, okay, it can be a rotational motion as well. So when a rod is rotating, then how much EMF is in it? Because when a rod, let's suppose this is your current carrying rod and now it is rotating about this axis, that means can you say still it is cutting the magnetic lines of forces? Still it is cutting magnetic lines of forces. And now if it is cutting magnetic lines of forces, how much EMF is getting induced? That is what we have to calculate. Okay, let's see. What we are going to do, we are going to integrate this question. How will be solving? Firstly check, I am telling you with the steps. कौन सा color है भाई? Take it red. Okay, we know the result for the linear motion, correct now? We know the result for the linear motion. Same way we are going to calculate. I will tell you how. Just follow me step by step. From this center point from about which it is moving, go at a distance x and cut out an element of thickness dx. Cut out an element of thickness dx and just focus on this dx element. What is the result of EMF? Small, due to the small effective element that we have taken, the result will be, what will be the result? Formula is BLV and you have to integrate it both the sides. Correct? I will be writing a magnetic field is constant. Magnetic field is constant. That's why I will write it as B. Now, what is the velocity that you will write? Velocity. What is the relation between velocity and omega? This is rotating with some omega. You can write V is equals to omega into R. Correct? That means if I have to write the velocity at this point, I can write this as omega into what is the distance that you have taken? X. That means what you will be writing as a velocity, it is omega into x. Now what is the length that you have cut it out? The length of your element is dx. Length of the element is dx. This is what you have to integrate, and I can say simply the integration is only for x dx, correct? And from where to where you have to integrate? From this point to this point, that is what the complete length of the rod. How I will be writing? Here x is equals to 0, here x is equals to L. So I will be integrating this result from 0 to L, correct? Now tell me, what is the integration of x dx? What is the integration of x dx? Batao. Integration of x dx is simply what? X square by 2. That means what you will be writing and putting the limits. Finally, the result that you will be getting, delta V, that is V0 minus Vx is equals to B omega L square by 2. This is the rotational EMF that you will be saying. When your current carrying conductor is rotating about a fixed point with angular velocity omega, what is the EMF that will be generated into your current carrying conductor? That is equals to half of B omega L square. Is it clear to you? Is it clear? Very clear? Very good. So let's see some question that we can solve from here. पहले तो question पढ़ लो यार, otherwise it will be hidden from here. So what is the question? A metal rod of length L, okay, it rotates about the end of a uniform angular velocity omega. Okay, it starts rotating with angular velocity omega. Very good. A uniform magnetic field exists B, that is also given in the direction of the axis of rotation. Calculate the EMF induced between point X and Y. Between point X and Y, how much EMF is generated? Neglect the centripetal force acting on the free electrons as they move in the circular path. Okay, you have to calculate the EMF between point X and Y. अब कुछ मूर्ख क्या बोलेंगे? Some murk will be saying that I know where you will be making mistake. You will be simply saying, sir, this is L by 2, this is L by 2. Simply apply the formula half B omega L square, and the place of L square, some students will be doing this mistake, very common, that they will be directly taking this L by 2 whole square. So finally, what is the result that you will be getting? It will be simply divided by a factor of 8. Correct? This is what the mistake that you are going to do. I know this. So what is the correct way? Why I am not applying that? Because you remember how we have written. I know that there is some glitch, but problem is that the board is lagging. The natural pen is not coming. I have tried switch off it and switch on the system also 2 times. बीच में मैंने switch off switch on किया, कुछ काम नहीं कर रहा. कल भी हो रहा था, फिर पढ़ाऊंगा कैसे? और ये पेन का थिकनेस बहुत पतला है. Will tell you. So how we are going to solve this question? Understand here. What we'll be doing, we are knowing, I have told you that it is very good that you are remembering the result. That is one thing. But what is the second thing? We always taking the rotation from the point O. We are always taking the rotation from point O because we should understand what from where we have derived and how we have derived. So I will tell you how. There are 2 methods. Let's discuss both the methods. How will we doing? Let's erase this. Firstly, let's discuss the method 1. What is the method 1? I will tell you. Results are not as important. You should understand the method. Method 1 says that if I am saying that it should be from the rotation point, what I can write the first equation, I will write potential between O and X. Potential difference between point O and X. How I will be writing? VO minus Vx. Let's write for complete. How I will be writing? What is the formula? Direct formula I can apply. Half B omega L square. That means I will be writing it as half B omega L square. Half B omega L square because the length is L. Simple, no problem. This I will note as equation 1. This I will be writing as equation 1. What I will be writing as equation 2, that is, I will write for this part only, VO minus VY, potential difference across this section only, point between point O and Y. How I will be simply writing? Again, I can use the direct formula, half B omega, but at the place of writing the L length, I will be writing L square by 4, L by 2 whole square, exactly that is the point. Correct? Now you have 2 equations, 2 variable. Can I simply do? I will subtract both these equations. I will do what? I will do equation 1 minus equation 2. And when I am doing equation 1 minus equation 2, I will simply get my what I want to calculate, Vy minus Vx. If you want to do Vy minus Vx, you can do simply correct, you can do equation 1 minus equation 2. Vy will become positive, and the rest of the things you can easily solve. Kar lo solve, the easily you will get the result. Correct? Samajh aaya? Now this was the one method. What is the second method? Second method, you can go conventionally. How you can go conventionally, that also I will tell you. See what you want to calculate for this portion. Correct? Go at a distance x, the first derivation that you have did, go at a distance x and cut out an element between this portion y and x, and now just focus on this y and x. What is the velocity? You will be saying again, oh sir, omega into x. Correct? And how will be writing the EMF? EMF you will be writing as B into L into V integration. I will be writing magnetic field B simply. What is the velocity? You will be writing omega into x. Correct? The same way we have derived this result. And what is the length that you have taken? That is equals to dx. But the change that will be coming will be only in the limits of integration. Limits of integration will be, because you don't want to integrate this complete rod, you want to integrate only from this y point to this x point. That means what I can say, the limits of integration will be from L by 2 to L only, and that's it. That is what is going to give you the result. Clear? So both are the ways that are open for you. I have told you from both the ways how you can calculate. If you are using the direct formula, you should be smarter enough that you understand the points. If you want to go from the derivation, then there is no problem. From the derivation you can do anything from scratch. Correct? This is what the final result that you will be getting, and how this can be solved. Alternate method, that also I have told you, go for the integration, just the limits of integration will be changing from L by 2 to L. That is also we have already discussed. So one more thing, let's suppose it is rotating with some omega. It is rotating with some omega. Okay, a random loop I have taken. I have told you about this concept in calculating the force on a loop, that only calculate the effective length, because L vector that you are taking, that is a displacement vector. So you don't have to worry for this complete row. You want to calculate the potential difference between point A and B, correct now? So just simply watch what is the L vector that is going to come. Simply worry for only L vector, nothing else. No need to worry for what is a complete length. Just simply check the L effective length and just mention that into the formula. That's it. That will be helping you. Same kind of question here also. What this question is saying, read the question. Simple question is saying, asking you about Vx minus Vy. You have to calculate Vx minus Vy. How you will be calculating? Let's see. Vx minus Vy. See how you will be writing this. Again, this is rotating about this point omega. So whatever the result that we are going to write it about omega, about point O. Okay, I can simply say, you can write the potential difference that will be generated in this wire, and you know the basic formula. I will write the potential difference between point O and X. How you will be writing? You will be writing VO minus Vx, and what you have to calculate? You have to calculate Vx minus Vy, as I remember. Vx minus Vy, exactly. Okay, so you will be writing this, that is equals to half B omega L square. At the place of L square, what you will be writing? You will be writing that is equals to 4 square. Clear? Any doubt? Now what you will be doing? You have to calculate the potential difference across this, but it is not the point of rotation, so I will be directly applying the formula. We got stuck. But I can do one more thing. Can I write potential difference between point O and point Y? Sir, there is no wire. I have told you now that calculate the effective length. Just the last slide I have explained you. Calculate the effective length now. You don't have to worry for the rest of the things, because it is connected. That means of course some potential difference will be generated, and L vector is what? Displacement vector. So calculate the distance, how much it will be coming. This is a perpendicular 4 3, that means Pythagoras theorem, this will be coming as 5. Now in the this is, let's assume this as equation 1. Now write the equation 2, VO minus Vy. VO minus Vy, what you will be doing? Half B omega L square. Effective length is 5, that means you will be doing what? 5 square. That is your equation 2. Now what you can do, simply subtract both these equations for finding this result. I will say do equation 2 minus equation 1. You will be getting what? Your desired result, that is Vx minus Vy. Or ye kar lo ki equation 1 minus equation 2, then add a minus sign also. So because you want to calculate what? Vx minus Vy, ultimately your result will be simply coming. Is it clear? So you don't have to worry for what will be how I will be calculating across this one. Just simply focus on the point about which it is rotating and just see the effective length that is coming, and that's it. That is what you have to understand. Otherwise you can apply the direct formula. There is no issue into that. And the result, the final answer also that I will be telling you, solve karoge, you will be getting the result as 9 by 2 into B omega. That is the final result that you will be getting. Is it clear? समझ आया? Now from next lecture we will be starting self inductance, that is about the electric component that we are going to study. Until next time, keep learning, keep growing with Tapasya. Endigu and Dendigu Nama Tapasya.